Hello students, welcome to PK's Learning Stations. Today we are going to discuss about nodal analysis method in electric circuits. So calculate the current flowing through the various resistors in the given circuit diagram using nodal analysis. The last class we discussed about mesh analysis. So today we can discuss nodal analysis. So when we are going for nodal analysis, we must know about the KCL. You should know about KCL, Kirchhoff's current law. What is Kirchhoff's current law? At a junction, at a junction, at a junction point, right? At a junction point or node point. At a junction point, sum of the current entering is equal to sum of the current leaving. Okay, sum of the current entering is equal to sum of the current leaving in a junction. This is the KCL. Okay, so we have to identify the number of nodes in the circuits. First, identify the number of nodes. Out of the nodes, the one node should be considered the reference node, that is the ground node. Okay, the potential of ground node is 0 volt. So, first you should know about what is the difference between node and junction point. The node is nothing but connecting point of two elements. If there is only two element was connecting, that point will be called as the node point. If it is a junction, we need minimum three elements should be connected, more than two elements, right? You can see here, this is the one junction point which is having a four elements. What are the four elements? One is the 25 amps, 10 ohm, 5 amps, 5 ohm. All the four elements, one will be 25 is connected, 10 is connected, this 5 amps is connected, 5 ohm is connected, 4 words are connected, right? This we can take it as node A, junction point A. Next, come to here, same 5 ohm is connected, 5 amps is connected, 2 ohm is connected, 6 amps is connected. 4 elements are connected. The condition for junction point is more than 2. Okay, so this is one node. Then coming to the bottom, you should see, you should not take this and this as a separate node. If there is a element middle, we can take a separate nodes. There is no element in the bottom. All will be connecting like a shorted line. If that is the case, we have to assume it's a only one node. This is the ground node, zero node, right? Voltage for this node is 0 volt. The 6 ohm also connected here. This 25 amps also connected here. This 5 ohm also connected here. 2 ohm also connected here. This 6 amps also connected here. So the four elements are connected here. Okay. So if there is a resistor in between, then consider as a separate junction point. Otherwise, take a common. Okay. If there is only shorter line is connected, then take it as a common. Most commonly take the bottom as a ground node. Right. So here only two nodes A and B. We have two junction points. So the nodal analysis, you must consider only a junction point as a nodes. Junction point as a nodes. What is junction point? Connecting more than two elements, or minimum three elements should be connecting point. Okay. So two nodes A and B, right? So I need to identify, I have to assume that the node voltages, the node A voltages I consider as the VA, the node B voltage I consider as VB. The node A voltage I consider as VA, node B voltage I consider as VB. What is the meaning of node voltage? The node voltage is nothing but voltage between the node to ground. Voltage between the node to ground. This is the node voltage. The voltage between the node to ground. That is nothing but node voltage. Remember this. What is the node voltage? The corresponding node to ground. voltage of the node voltage. Okay, this is for understanding. I written it here, so we are not using this V and R. Okay, yes. Now we go for applying a KCL at each node. The same thing earlier we identify the number of meshes, we apply KVL at each mesh. The same thing. Here we identify the number of junction points. So apply a KCL at each junction point. Okay. Now I am going to apply a KCL at node A. Apply KCL at node A. KCL at node A. Okay. When you are applying a KCL at node A, you have to assume the unknown currents. What are the unknown currents is? So wherever the resistor is located, the current flowing through the resistor should be assumed. You have to identify the current flowing through the each resistors. So there is a 10 ohm resistors current. So normally the resistor will consume the only consume, right? Don't supply anything. Okay. So I assume the current draw by 10 ohm resistors I1. Current draw 5 ohm resistor is I2. Okay, I2, right? Okay, I'm assumed as I2. Okay, I assumed as current I2. The current flowing through the 10 ohm resistor is I1. Current flowing through 5 ohm resistor is I2. Then I will assume the current flowing through 2 ohm resistor is I3. Assume the current flowing through each resistors I1, I2, I3. Then you want to write it what is I1, what is I2, and what is I3. Okay, you can see here. If you are going to find the current flowing through the resistor, for example, we can take the current flowing through 5 ohm resistor. Okay, the 5 ohm resistor is connected between the two voltages. The terminal, right? The terminal A voltage is VA, terminal B voltage is VB. Then identify the voltage across 5 ohm resistor and the current. Current is nothing but I2. Current is nothing but I2. Okay, the current is nothing but I2. Okay, yes. So now, according to the Ohm's law, what is the Ohm's law? At a constant temperature, V is equal to IR. The here also the V is equal to 5 I2. So V is nothing but I2 into 5 I2. What is V here? The V is nothing but potential difference between the two nodes. The node 1 voltage is VA, the node 2 potential is VB. The node A potential is VA, node B potential is VB. This is the node A, this is the node B. Okay, the node A potential is VA, node B potential is VB. I want to find out the voltage across AB. So take a potential difference. So the V is nothing but VA minus VB, which is equal to 5I2. What is I2 here? For I2 is nothing but VA minus VB by 5. Then you can remember this. If you are going to find the current I2, then the starting voltage VA minus end voltage VB divided by the resistance. So I is equal to V by R. V is nothing but potential difference. Remember this, divided by the resistance. Okay. So amps. Similarly, what about next to 10 ohm resistance? Similarly, for 10 ohm resistance, right? Your 10 ohm resistance is connected like this. Node A to ground. Okay. So this voltage is 0 volt. This voltage is VA. What is the resistor? 10 ohm. The current which is flowing through this 10 ohm is I1. Then what is I1 now? Potential difference VA minus 0, right? VA minus 0 by 10. amps. Okay. Similarly, what about 2 ohm resistor? The same way, we can go for 2 ohm resistance. Okay. What is the 2 ohm resistance? Terminal B, the voltage is VB. Again, this is ground, 0, 0 volt, 2 ohm resistance. Current flow in this one is I3. What is my I3? My I3 is nothing but same, VB minus 0 by 2 amps. So this is all about it, right? Now we can go for finding applying the KCL for each node. Okay. Yes, you can see now. I will take a node A, right? So what are the current entering? This 25 amps is entering. So the sum of the current entering is 25. And then what are the currents? This leaving, and this leaving. Three currents are leaving. Only one current is entering. Three currents are leaving. So entry current is only one. What are the currents is leaving? 5 amps is leaving. 5 plus. Then I1 and I2 are leaving. I1 plus I2. Substitute the values and find out these equations. This 5 will move this side. 25 minus 5, right? What is that? What is 25 minus 5, which is equal to, this is I1, VA by 10. I1 is nothing but VA by 10, VA by 10 plus, what about your I2, VA minus VB by 5. Both are leaving, right? VA minus VB by 5. VA minus VB by 5. Take the LCM, what happened? Here it is a 20, right? Here it is a 20. Got it? Don't get confused. This side should be a 20. 20 is equal to, taking the LCM. What is the LCM? LCM will be a 10. This will be multiplied with 1 VA. This will be multiplied with 2. 2 VA minus 2 VB. Taking LCM, right? The 10 will be LCM. So here already 10 is there. So multiple with 1. So this is 5. So making a 10, we need to multiple with 2. So 2 VA minus 2 VB. Now the 10 will be coming, this side is 200. 3 VA, right? What is the answer is? 3 VA minus 2 VB is equal to, this 10 will be multiplied here. 20 plus 10 is 200. This is the equation number 1. This is equation number 1. Okay. Next I am going to apply KCL at node 2. Okay. Apply KCL at node B. At node B. Okay. So this is node B. So same like a 4 currents. Okay. We know that current flowing through 5 ohm is known. Current flowing through 2 ohm is known. 5 amps and 6 amps same. Yes. I'm going to write the next. Yes. Yes. What are the equations now? So for node B, what are the currents is entering? What are the currents are leaving? So the entering currents are I2 and 5 ohms are entering. This I3 and 6 are leaving. Okay. So I2 plus 5 amps currents are entering, right? So this I2 is entering, 5 amps is entering, so I2 plus 5. This I3 and 6 will be leaving. Okay. So I am writing on the leaving side, I3 plus 6. Now I want to move this I2 this side, this 6 this side. No, I will take 5 this side, I3 this side. Okay. So what happened now? So Now I2 minus I3. I2 minus I3, which is equal to 6 minus 5. Now what is my I2? VA minus VB by 5 minus VB by 2, which is equal to 1. Which is equal to 1. We have to simplify this. How to simplify this? Normal simplification. Take a LCM. So 5 to the LCM again it is a 10. Again the LCM will be a 10. This side is 1, right? So this will be multiplied with 2. 2 VA minus 2 VB, and then this will be multiplied with 5 minus 5 VB minus 5 VB. Now this bring this 10 to this side. What happened? So 2 VA minus 7 VB is equal to 10. Equation number 2. By solving the equation 1 and 2, what is the equation 1? So 3 VA minus 2 VB, which is equal to 200. Equation number 1. Next 2 VA minus 7 VB is equal to 10. Equation number 2. Same, the both the equation you can solve by grammar rule or equation mode, right? Now what is the number of unknowns? Now the number of unknowns is only 2. Now the number of unknowns is 2. So you have to choose the number of unknown as 2. Yes. So these coefficients are A. So this will be a, this will be B, and this will be C. Okay. So A1 VA minus B1 VB is equal to C1. A2 B2 C2. Okay. Yes. What about your VA and VB now? What is VA and what is VB? Yes. By solving this. So 3 minus 2, 200. Then 2 minus 7, 10. For solving this, the answer is 81.18 volts. Right. Next, what about your V2? Your V2 is 21.76. 21.76 volts. So, what is our question? Calculate the current flowing through the various resistors. Already we identify the various resistors. The current flowing through the 10 ohm is I1. Current flowing through the 5 ohm resistor is I2. Current flowing through the 2 ohm resistor is I3. We already find out. You know what is I1, what is I2, and you have to find out now, right? Yes. Yes. What about current flowing through this 10 ohm resistor? Nothing but I1, which is nothing but VA by 10. What is my VA? 81.18 divided by 10, which is nothing but 8.118 amps. Then current flowing through 5 ohm resistor is I2. What is I2? VA minus VB by 5. 81.8 minus 21.76 divided by 5. So what is my answer now? 81.8, 81.8, so 81.18, right? 81. 18, 81.18 minus 21.76 divided by 5. The answer is 11.88. 11.88 amps. Next, what about the current flowing through 2 ohm resistance? I3, which is nothing but VB by 2. VB by 2. Okay. What is my VB? 21.76 divided by 2. 21.76 divided by 2. The answer is 10.88 amps. Yes. These are the current flowing through the various resistors. Again the same problem we can also solve by matrix method. Same problem we can also solve by matrix method. Yes. Okay, I can do the same thing. Yes. Okay. Yes. We'll take the circuit. So from this circuit, we are going to solve by matrix method. Okay. Same problem we can also solve by matrix method. Yes. Okay. So again the same. Identify the nodes. We already identify the nodes. This is the node A. Voltage for the node A is VA. This is the node B. We identify the voltage for V is VB and the ground node. Right? We can go for the matrix method. So the matrix method as per the KCL. KCL is what? Current, right? I is equal to V by R. Then here the matrix is 1 by R matrix into V is equal to I matrix. Here also the same. V and I matrix are only column matrix, where R matrix is a square matrix. The size of 1 by R matrix is the 1 by R matrix is square matrix. The size will be the number of the junction points. Okay, that unknown values, two nodes A and B, right? So this should be a square matrix. The size is 2 cross 2. So the voltage is column matrix 2 cross 1. The current is also column matrix 2 cross 1. Okay. Now we can form a 1 by R matrix. So the size of 1 by R matrix is yes 2 cross 2. Yes. Yes. The size will be 2 cross 2. I will put a 2 cross 2. So similar to your mesh analysis, same diagonal element, right? All those things we can see one by one. V1, V2 unknown voltages, right? We are put it as VA and VB. VA and then VB. Okay. VA and then VB, which is equal to S equal to current, right? Here also the current, right? You want to put it as if the entering current entering to the node is plus, Current entering, leaving from the node is minus. Current entering to the node is plus, leaving to the node is minus. So now I have to fill this. Yes. You can see very simple. So similarly here we are writing the matrix in the structure of 1 by R. Earlier in the mesh analysis we write the R matrix, right? We added the resistance directly. But here we take a reciprocal and add. That's it. So here also the two rows, two columns. The row 1, column 1 will represent node 1. Column 2, node 2 will represent node 2. Okay, sorry. Yes, column 2, no, row 2 will be node 2. Yes. So what are the resistors connected with the node 1? The resistors connected with the node A is 5 and 10. Take a reciprocal of each and add. Same. The diagonals are adding, but here adding by reciprocal of the resistance. So one is 5 ohm is connected, take a reciprocal of the 5 ohm is 1 by 5 plus another 10 ohm is connected, take a reciprocal of the 10, 1 by 10, both will be added. Next coming to the second diagonal, what happened? Going to the second node, what are the resistors? 5 ohm and 2 ohm is connected. So then reciprocal of 5, 1 by 5 plus reciprocal of 2, 1 by 2, two resistors. Now coming to the off diagonal. When I coming to the off diagonal, we have to identify the common resistance connected between the nodes. The common resistance connected between the nodes. So node A and B, 5 ohm resistor is connected. Here always negative of the reciprocal of the resistance. Always negative. Why I am saying always negative? Because when you are assuming the current I2, the current I2 is flow from A to B. When you are coming to the node A, the current is leaving. When I compare to the node B, current is entering. So both are opposite, right? The one node it was leaving, another node it was entering. So always minus. The here also minus 1 by 5. Element 1, 2 and 2, 1 should be same. So what about this right hand side? The right hand side is you want to put the values, right? Current values. What is the current value? So as per the node 1, the current is entering means plus. So here the 25 amps is entering. So plus 25. Then there is another current source is connected with the node A, that is 5 amps. That 5 amps is leaving. If the current is leaving, minus. So you identify the number of current source connected with the node. So check each current source. If the current source is entering, plus of that value. If the current is leaving, minus of that value. That's it. So 25 amps is entering, so plus 25. The 5 amps is leaving, so minus 5. Similarly, coming to the node 2, the 5 amps is entering. 5 amps is entering, so plus 5. This 6 amps is leaving, minus 6. Okay, so you identify these values. 1 by 5 plus 1 by 10 you can identify, or you can type these values directly in your calculator. The calculator will calculate the values. Okay, you check this and identify the VA and VB. VA and VB. Once you identify the VA and VB, you can find out the current for the each resistance by the previous what we did here, right? VA by 10, VA minus B, B by 5, VB by 2. That way you can calculate. Okay, so what is one VA and VB? You can see. So phi inverse plus 10 inverse for the first diagonal, then minus phi inverse, then 25 minus 5. So type your calculator directly. Okay, so then minus phi inverse plus 2 inverse, then finally 5 minus 6. The values are same, 81.18 volts, and then the VT is 21.76 volts. The remaining, once you got VA and VB, the remaining will be as per this procedure. Okay, either we can use method 1 or method 2. Either if you are easy with the matrix, you can solve a matrix. And what is the condition for solving in matrix is, so we have all the current sources, right? We have all the sources are should be a current source. If you have any voltage source, then that should be a series with resistance. Voltage source, if you have the nodal analysis, sometimes the problem will be asked by solved by nodal analysis. So there will be voltage source is present. Then the voltage source must have a series of resistance to solve by matrix method. Okay. So we will see the one more problem with the voltage source and current source combination in the next video. Okay. So thank you for watching the video. Thank you for all. If any doubts, kindly enter it in the comment window. Okay. Thank you for all.